This video is going to cover the topic of linear modeling. So this isn't really too much new, but we're going to be putting a lot of skills together. So we're going to need to write ordered pairs, remember how to write the equation of a line, and then use that line. So example number 1 is about cricket chirps. It says the rate at which a cricket chirps is a linear function of temperature. At 59 degrees Fahrenheit, a cricket chirps 76 times per minute. At 65 degrees Fahrenheit, a cricket chirps 100 times per minute. Part A, define your variables. So we need to figure out what our variables are and which one makes sense for X and which one makes sense for Y. In this case, we are given a temperature and we are given a rate at which the cricket chirps. So one of those is going to be X and one is going to be Y. Now, it matters which one you put as X and which one you put as Y. X is our independent variable. So X will be affecting Y. So we need to ask ourselves, does the temperature affect the rate at which a cricket chirps? Or does the rate at which a cricket chirps affect the temperature? Well, a cricket doesn't affect the temperature. The temperature affects the cricket. So X, the independent variable, is going to be the temperature. Specifically in degrees Fahrenheit. Y is the cricket chirps. Don't just write cricket though. What about the cricket? Y is going to be the number of chirps per minute. So then we're going to need to write two ordered pairs. Quick note in A, if you define X and Y wrong, it's going to mess the rest of the problem up. So we need to make sure that we are very careful when we are labeling which one is X and which one is Y. So writing your two ordered pairs. First, we know at 59 degrees, the cricket is going to chirp 76 times a minute. It also says at 65 degrees, the cricket chirps 100 times per minute. So those are our two ordered pairs. Part C, determine the linear equation relating temperature to number of cricket chirps per minute. So we're writing a line, writing an equation of a line. Anytime we're writing an equation of a line, we need to calculate the slope. So we're going to start with that. If you remember, it's going to be y2 minus y1 over x2 minus x1. 100 minus 76 is 24. And then 65 minus 59 is 6. So we end up with 4. Now, units are important here. If you remember, y is in our numerator and x is in our denominator. So we're going to use those units. The units for y are chirps per minute. The unit for X is degrees Fahrenheit. So what this is telling us is every time the temperature increases by 1, the cricket chirps 4 extra times a minute. So every time we increase the temperature by 1, the cricket is going to chirp 4 more times per minute. Now we need to remember to answer the question, which in this case is writing the equation of the line. So we're going to use point slope form. It doesn't matter what point we use. So I'm going to use that point that has 100. Now, perfectly okay if you leave your answer like that. We, though, are going to be using this equation of the line later, so I would suggest you convert to slope-intercept form, y equals mx plus b, because it's easier to work with. So if I distribute that 4, I get y minus 100 equals 4x minus 260. If I add 100, I get y equals 4x minus 160. Now again, if you leave your answer in point slope, that's fine. It just might be a little more difficult to use later. Okay, if we go on to D, use your equation to predict the number of cricket chirps. Predict the number of cricket chirps, so that's y, when the temperature is 79, that's X. So that's telling us if X is 79, predict Y. Using our equation, we get 4 times 79 minus 160. If you put that in your calculator, you get Y to be 156. Make sure you put your units though. So the units for Y are chirps per minute. If we look at E, use your equation to predict the temperature, so that's X, when a cricket is chirping 44 times a minute, that's Y. So in this case, we're given Y, we need to find X. If we put 44 in for Y, we're going to add 160 to both sides. So we get 204 is equal to 4x. If you divide by 4, you get x to be 51. Remember units though, so this is temperature. Our units then are degrees Fahrenheit. Okay, so none of that is really new. F and G are a little bit new. So F, explain the meaning of the temperature-intercept. Okay, so if we think about the x-intercept, for example, x-intercept means that y is 0. So if I'm asking you for the temperature-intercept, I mean that the other variable is 0. So this is saying find temperature when the other variable, which is chirps, is equal to 0. Okay, chirps is your y, so really we're finding x when y is 0. So using our equation, we plug in a 0 for y. If I add 160 to both sides, I get 160 is equal to 4x, so x equals 40. So our intercept is 40, 0. We need to explain what that intercept means. So that 40 of x, that's the temperature. So when the temperature is 40 degrees Fahrenheit, we predict that the cricket will chirp 0 times per minute. Okay, so then in G, explain the meaning of the number of chirps intercept. So number of chirps, that means the other variable is 0. So we need to find the number of chirps when the temperature is 0. The temperature, that's x. So we're going to plug in a 0 for x and find y. Well, using our equation, we get 4 times 0 minus 160, which is 0 minus 160, which gives us negative 160. So when x is 0, y is negative 160. Now, again, we need to explain the meaning of this. So in this case, when x is 0, when the temperature is 0 degrees Fahrenheit, we predict the cricket will chirp negative 160 times per minute. Now, we need to ask ourselves, does that make sense? No. We all know that. That doesn't make sense. That's okay. It's still the right answer. So this is something we call extrapolation. So extrapolation happens when you use your equation for inappropriate values of x and y. So in this case, when we use x or a temperature to be 0, we get a y that doesn't make sense. That's okay. That happens. So that is the basic idea of linear modeling. Here's what I would like you to do before you come to class tomorrow. We're going to take a look at this next page. Okay, so this next page is another linear modeling problem about Bay Village. You're not going to do the whole problem. What I want you to do for tomorrow is parts A, B, and C. So I want you to define your variables, write 2 ordered pairs, and determine the equation. Instead of t, you're going to use x. So for tomorrow, or for the next class period, please do parts A, B, and C, and I will check when you come into class. If you have any questions, please make sure you write them down.